Hey everyone. So in this video, I'd like to talk about evaluating expressions that include negative numbers. And some of these expressions will include variables and some of them won't. So let's start off with a few examples that do not include any variables. And so before we begin, I'd like to remind you that whenever we're evaluating expressions with variables or without variables, we still have to follow order of operations. And so let me rewrite that acronym here. Right, so PEMDAS, right? Parentheses, exponents, multiplication and division, and then addition and subtraction, right? That's the order in which we want to evaluate an expression. And so let me ask you to pause the video and try these two examples out yourself first before we go over them together. So order of operations tells us to start with parentheses and other grouping symbols, and here, although we have parentheses, they're not really telling us anything more to do. They're just separating out these negative values, making it very clear that they're negative and not subtraction. And then exponents, well, there aren't any exponents either, so we can move on towards multiplication and division. And so there is multiplication in this expression, right? There's 7 times negative 3, and there's subtraction of 2 times negative 5. And so let's perform that multiplication. So 7 times negative 3, this comes out to be, well, here the signs differ between these two quantities being multiplied, and so it's going to give us a negative result, negative 21. And then here, I'm going to keep this subtraction. I'm going to write down the subtraction. And the next thing we have to do is we have to multiply 2 times negative 5. And so this gives us negative 10. Right? The signs differ, so we're going to have a negative result from this product. And then here, 2 times negative 5, well, that'll give us that negative 10. And then here, if I want to subtract negative 10, well, subtraction I can view as adding the opposite, right? So here I'm going to rewrite this as a negative 21. I'm going to rewrite the subtraction as addition of the opposite of negative 10. Well, the opposite of negative 10 is positive 10. So we have negative 21 plus 10. Now, what does this give us? And this might be a tricky example of negative addition. But here this comes out to be negative 11, right? If I have negative $21 in debt and I have $10, I can pay some of it off, but I'd be still left with $11 of debt. So here my result is negative 11. And actually, we evaluated this expression one way, but maybe let me show you another way we can evaluate this expression. So here I'm going to rewrite it down below. So this is 7 times negative 3 minus 2 times negative 5. So one thing I can do here, I'm still following order of operations, but I can slightly translate this expression. I can rewrite this as we saw earlier, we can rewrite subtraction as adding the opposite of the next quantity, right? So here, I'm not performing order of operations any differently, I'm just translating my expression before I actually perform any of the operations. I'm going to rewrite this minus 2 times negative 5. I'm going to rewrite that as adding the opposite of 2. So this is going to be negative 2 times negative 5. And actually, if we work through this example, we get the same result. And so this is going to be 7 times negative 3. That's a negative 21 as we saw earlier. I have plus, and then negative 2 times negative 5. Well, when the signs of two quantities that we multiply are the same, the result will be positive, right? So negative 2 times negative 5, that comes out to be positive 10. And as we saw earlier, that's the exact same thing we got at this line here. All right, so negative 21 plus 10, that comes out to be negative 11. All right, so all I did in this time that I evaluated this expression was I just converted this subtraction problem into an addition problem by rewriting the next part of our expression as the opposite, right? So subtraction is adding the opposite. So let's move on to this next example here. So 9 minus 4 times negative 6. And so if you haven't already tried to work out this example, let me again ask you to pause and do so. So the first thing I like to mention with this example is that here this minus 6 that's really not a subtraction of 6, but it's really referring to the quantity negative 6. Right, so we don't want to view that negative 6 as subtraction. Here it's wrapped in parentheses to really tell us that we're looking at the number negative 6, not subtraction of 6. And so how is this negative 6 being connected or tied together with the other parts of our expression? Well, here, because there's no operation between this 4 and this negative 6, it's telling us that we're really looking at multiplication. Right? The multiplication is implied. And so here, if I have 9 minus 4 times negative 6, I'm going to perform that multiplication before that subtraction, right? So here it would be incorrect to try and subtract away 9 minus 4. So here we get 9, and I'm going to rewrite this as minus. So we see this 4 times negative 6. Well, 4 times negative 6, we know that comes out to be, well, the signs differ, so it's going to be negative. 4 times 6 gives us 24. Right, so I still have the subtraction. I didn't do anything with that. And I just multiplied the 4 and then negative 6 to get negative 24. And now we can rewrite this as 9 plus 24. Right, subtracting negative 24 is the same as adding the opposite of negative 24, or in other words, adding positive 24. And then this comes out to be positive 33. And again, we could have jumped straight to this step here, actually just by viewing this 9 minus 4 times negative 6, viewing this negative, or the subtraction of 4 as adding the opposite, right? Just writing this or viewing this as 9 plus negative 4 times negative 6. And this gives us 9 plus, and then here, negative 4 times negative 6 gives us positive 24, which we get 33 out again. So here's another example where we have to evaluate this expression, and it involves negative numbers. Definitely try this out first before we go over this together. So the first thing we want to do is we want to look inside the parentheses. Our parentheses are telling us what to begin with, and we want to evaluate this expression before anything else. Okay, well, within these parentheses, we want to again follow order of operations, and the parentheses we see within these parentheses, there's no operations to compute inside of them. They're just telling us, hey, this is a negative 5 and this is a negative 2. So now, we just want to compute the result inside this set of purple parentheses. There's really just addition and subtraction here, and so we work this out from left to right. So this is equal to, well, we still have that 4 minus 3. We don't want to compute that because there's multiplication involved with the parentheses on the right. So we have negative 6 plus negative 5. This is negative 11, right? If I owe $6, I owe 5. Put them together, I still owe 11. And then we have minus negative 2. And then next we have to subtract negative 2, and that's like adding the opposite of negative 2. So this is going to be the same as adding 2 to negative 11, right? So this is negative 11 plus 2. And negative 11 plus 2, this is going to give us negative 9, right? Because if I owe $11 and I have 2, I could pay some of that off, get rid of a little bit of debt, but I still owe 9. And then next we have multiplication here, right? No operation, this is telling us multiplication, so we have 4 minus 3 times negative 9. So I'm still going to keep this minus sign here, just for simplicity, and I'm just going to look at this 3 times this negative 9 to give us negative 27. But the signs are different between 3 and negative 9 when I multiply them, so the result is going to be negative. And then when I subtract away that negative, I can read that as addition of positive 27, giving us 31. So next, let's evaluate this expression that includes variables. And we're given the values of these variables. Here we're told to find or compute the result when x is equal to 5, and compute the result when y is equal to 2. So here, that just means wherever I see x in my expression, replace that with the value 5. So here, or not 5, negative 5. And whenever we're evaluating or replacing the value of a variable, it's a good idea to wrap that replacement with parentheses. And I'll go over an example of why that might be beneficial in just a moment, but let's just go ahead and do that and work through this example. So I have negative 3 times x, and again, we've already said that x is going to represent negative 5 in this case. So I'm going to replace that different x term, that x variable in the different term, by that same negative 5. And then again, we still have to multiply that with y, which is negative 2. And the fact that I don't have any operations between these different values, right, 2 and negative 5, or 3, negative 5, and negative 2 is telling us that they're being multiplied together. Okay, so here, we want to perform order of operations. We want to perform the multiplication before the subtraction. And so this gives us 2 times negative 5 is negative 10. Then we still have that minus sign, and then I'm just going to look at this part here, boxed in purple or in pink. So 3 times negative 5 gives us negative 15. So I'm going to do this one step at a time. This is negative 15, and we still have this as multiplied with a negative 2. And then this is equal to negative 10, and I still have this subtraction sign. But I'm going to perform the next multiplication, which is negative 15 times negative 2. Well, the signs are the same, so the result is going to be positive from this multiplication. There's going to be positive 30 that I'm subtracting away, right? So here, I didn't think about that negative or this minus sign in that computation at all. I was really just worried about the fact that these two quantities are negative and they're multiplied together to give me this positive 30 that's still being subtracted here. Okay, so now to compute this result, well, I'm going to read that subtraction as adding the opposite of positive 30. I'm going to read it as adding negative 30. Right? Subtraction is, that translation is really helpful for us when we're dealing with negative numbers. And so negative 10 plus negative 30, if I owe $10 and owe 30 more, this is the same as owing $40. So here our final result is negative 40. So I said earlier that whenever we want to evaluate an expression and we're replacing variables with some numbers, it's beneficial for us to include parentheses around those replacements. And here this is a really good example of why that's a beneficial thing for us to do, is if I didn't wrap those parentheses around the substitution, if I just wrote 2 and negative 5 here, even if I put a little dot between the two to say multiplication, it can be kind of confusing to look at that. It might be accidentally interpreted as subtraction, right? That negative sign here before that 5, that's not telling us subtraction at all. That's telling us that this quantity is a negative quantity. But in our expression, we're told that 2 and x ought to be multiplied together. And so we don't want to interpret this negative sign as subtraction. Really, that ought to be multiplication. Right, so that's why that parentheses is beneficial for us, is because it really signifies that that negative sign is negative, not subtraction, and that we can view this as 2 times negative 5. And then of course there's more to our expression, but I think that's enough to illustrate the benefit of wrapping our substitutions or replacements in parentheses. So let's do this again for p minus, in parentheses, 4 minus m. I encourage you to try this example out yourself first. So here, I'm going to use blue for p and green for m. We're saying p can be replaced with negative 2, and m can be replaced with negative 6. So this gives us negative 2. And here actually the parentheses aren't the most important for p, because there's no confusion that whether we're doing subtraction or addition or multiplication here. So it's still nice to have them there for consistency, but that might not be the most important. Here is where it might be beneficial to write 4 minus, and then m is equal to negative 6. So I'm going to wrap that in parentheses. So this is the same as negative 2 minus 4, subtracting the opposite of negative 6 gives us plus 6. And I'm doing that step first because really, these are the parentheses I want to evaluate first. Parentheses tell us what to do first, and there's no operation to really do or perform in this set of parentheses, so I'm going to look at my next set of parentheses. And so this is -2 minus 10 here, right? 4 plus 6 is 10, and this is -2. I'm going to view this as plus -10, which comes out to be -12. So let's take a look at one last example of evaluating an expression, but this time one where one of the variables has an exponent. And so please pause the video and try this example out yourself first. Okay, so we're asked to evaluate this expression, and we're given the values of a, b, and c. So all we have to do is we need to just plug these values into our variables in our expression and then calculate the result. And so here the expression is asking us to square the value of b. So we're going to take -5 and we're going to square it. We're going to then subtract away 4 times the value of a, which is 4 times -1. So again, not subtraction here. I'm going to emphasize that by wrapping that -1 in parentheses. And then we're going to multiply this with the value of c, which is 3. And so here we have to follow order of operations, and there's not much to compute inside the parentheses, so we can move on to exponentiation. And here, the exponent to compute is -5 squared, which is just -5 multiplied with -5, or in other words, 25. And then there's no more exponentiation. So next we move on to multiplication and division. And here on the right side of this expression, we have a series of multiplication to perform. And so I'm going to rewrite this. I'm going to rewrite it as 25 minus, just keeping that subtraction sign here. This is the same subtraction sign. And I'm going to start the multiplication. So 4 times -1. Well, it's going to come out to be -4. And I still have this 3 to multiply afterwards. And then next, we still have 25 minus, and then I'm going to perform this next set of multiplication. So we've got -4 times 3, that comes out to be -12. And then subtraction is just adding the opposite, so I could rewrite this as, instead of 25 minus -12, I'm going to add the opposite of -12 to get +12 there. 25 plus 12 gives me 37, right? If I add 10, I get 35, and then I add 2 more, that takes me to 37. Okay, so let me go over one last way of performing or evaluating this expression, maybe from, let's say from this step here. Right, so as we saw earlier, we can sort of translate the subtraction here to rewrite this as 25. Here I can write this as plus -4 times -1 times 3. And this gives us 25 plus, and now there's a lot less ambiguity for how we should multiply this out. So I'm going to multiply -4 times -1 to give us +4. And then here we still have a multiplication of 3. And then before I perform that addition, I'm going to still finish up my multiplication and get 25 plus 12, just like we did earlier, which we saw was +37.